Hello, my name is Markus Wirth. I'm a PhD student at the Machine Learning and Data Analytics Lab of the Friedrich Alexander University Erlangen-Nuremberg in Germany. And today I want to introduce you our work on the topic of assessing personality traits of team athletes in virtual reality. When we look into today's elite sports, we realize that optimal physiological parameters for specific sports have been broadly researched, which enable an individualized assessment and training of athletes. Soccer players, for example, have different training routines depending on their position on the field, where they train individualized skills like agility or speed. Likewise, it is done for basketball and other team sports. With the strive of sports science to understand top athletes holistically, also other decisive factors like cognitive performance and personality traits of athletes become more important. Having a closer look on personality traits, we can say that they are important to analyze, since it can help to understand how athletes behave and perform under certain conditions, like, for example, how athletes deal with pressure in competitive situations, or how they perceive, process, and react to information in critical situations. Consequently, knowing the personality of an athlete can be an important decision factor for tactical decisions and team formation. One theoretical concept that defines an athlete's personality is motivational orientation, which includes action and state orientation. Athletes can be either action or state oriented in their cognitive decision processing and application of strategies. Therefore, action orientation is defined by processes where an individual focuses on action alternatives and plans to quickly overcome a present state and intended future ones. This means that action-oriented athletes try to fulfill a specific goal as fast as possible and hence tend to take high risks. Additionally, they quickly move past with failures. On the contrary, state orientation describes the cognitive processes that strongly focus on the present, past, and future state of an experience. State-oriented athletes focus more on non-task relevant situational information and future consequences and try to minimize risks. They struggle to move forward fast in terms of failure, contrary to their counterparts. Current state of the art to measure such personality traits is using validated questionnaires. While these provide memory and imagination-dependent subjective information, they fail to give context-based measurements of an athlete's behavior in specific situations. Furthermore, these questionnaires do not address a sport-specific domain but provide abstract formulations which result in a non-context-based specification of an athlete's personality. Hence, these type of evaluations do not define details about how such personality traits may influence performance in specific sport situations. Using VR for assessing how personality influences an athlete's performance in specific sport situations is promising, since it yields the ability to provide high immersion, a high level of control and repeatability, and the potential to provoke high emotional and mental attachment. So in our work, we addressed the research questions: if VR is a feasible assessment tool for investigating performance of action and state-oriented athletes, if the subjective perception in VR differ between personality types, and if these personality types influence the performance in virtual reality. When looking into previous research of VR sports assessment, we can see that different work assesses relevant physical and cognitive performance parameters, like, for example, in the work of Bidot and colleagues, where they investigate the perception action loop of handball goalkeepers in VR. Within their study, the influence of perception on decision-making for handball players was investigated. Another example is by Romeas and colleagues, which used 3D multiple object tracking training to assess and improve decision-making accuracy of soccer players in passing tasks. Personality-specific research was done by Raab and colleagues that by using a video projection simulation could show that there are performance and risk-taking differences between state and action-oriented basketball players. To our best of knowledge, there is no work that investigates the applicability of VR for the investigation of athletes' personality traits. To address this research gap, we created two environments in which soccer players had to perform under different conditions using foot interaction. We created a so-called training scenario, which can be classified as static since there is only view dynamic information presented to the user. The environment consisted of 12 circular equidistantly aligned color-coded goals and a centered 3x4 meter interaction zone for the soccer players. All goals were at the same size and randomly assigned to one of 4 colors so that 3 goals of each color were presented. For this task, participants were asked to score as many goals as possible over a period of 60 seconds within this virtual environment by shooting the spawned ball into its respective colored goal. Within the environment, the metrics of number of actions, action time, bonus goals and failure rate were measured. Also, 3 different distractors were explored, namely auditory, consisting of the sound of a cheering crowd. Visual was the depiction of cheering spectators within the simulation stadium, or a combination of both the sound and visualization of a cheering crowd. The second developed environment consisted of a soccer stadium and field with 10 dynamic match situations, which were defined by sports expert. The 10 match situations were divided into 5 offensive and defensive plays, distinguished by the position of the user on the field and the movement of the opponents. Participants at a given point in time received a pass, which he must either pass or keep with the objective of completing the actions most likely leading to a scored goal. Within the environment, the metrics of pass accuracy, quality of decision, action time, and number of perceived opponents were measured. We used the implemented environments to conduct a within-subject study, including a total of 24 participants. Participants performed within the environments multiple times and were split into action and state-oriented athletes using a validated questionnaire. Within the study, user experience, presence, and the previously introduced performance measures were evaluated. When looking at the results of our study, we can see that action-oriented players rated the user experience of the environments higher along all measured user experience dimensions. These results were significant for efficiency and stimulation. One reason for this could be that action-oriented players show a higher ability to cope with and regulate emotions, and hence tended to focus on specific tasks, including dealing with anxiety, confusion and uncertainty. These individuals also seem to perceive the experienced simulation as more stimulating. Another reason for these results could be that action-oriented participants were more focused on the presented task within the virtual environment and hence ignored unfamiliar properties of the simulation. When looking at the performance measures, we found significant differences between action and state-oriented players in terms of failure rate, pass accuracy, number of perceived opponents, and bonus goals. Especially interesting are the scored bonus goals and number of perceived opponents. Here, state-oriented players significantly outperformed the action-oriented players. This goes in line with the assumption that state-oriented players collect more information regarding the present and possible future states before making a decision. These results are supported by previous findings of Raab and colleagues. To conclude the talk, one can say that we could find significant differences between action and state-oriented soccer players in terms of user experience and performance measures. We therefore argue that VR is a feasible tool for giving insights regarding the behavior of different personality types in specific sport situations. In future work, more performance measures, like for example gaze behavior, and their validity in VR should be examined. Thank you very much for your attention.